reminder of what I just said, that there will be a quiz tomorrow over lessons, I think, 3.1 to 3.4. Okay, it won't go to 5 and won't go to 6 for sure. Okay? Today we're going to talk about relating slopes to parallel lines and perpendicular lines. There's some rules that we'll learn today that you probably have seen before, but you might not remember them. And they allow us to know the slope of parallel and perpendicular lines based on knowing the slope of other lines that are parallel or perpendicular to them. And so the first thing we'll get into is parallel lines have the same slope. Rule number 1, parallel lines have the same slope. And I'll pause this while you copy that down. I'm reminding you here what the rule for finding the slope is. And there's a couple lines here, L1 and L2. So help me out here. What's a couple ordered pairs on line 1? Like, say this one here. What's the ordered pair that goes to that point? -4, -2. Good. And what goes with this one? -4, 3. And so, if we use those two ordered pairs to find the slope of line 1, we're going to say y2 minus y1. Which one do you want to call y2? You want to call this point 1 or point 2?
Point 2.
Okay, and so we'll call this point 1. So y2 would be 3 minus y1, which would be a -2. And x2 would be -4, and x1 would be -4. And so remember, minus a negative becomes a positive. So 3 plus 2 is 5, and 4 plus -4, sorry. -4 plus 4 is 0. What's 5 divide 0? I didn't see, I had my head turned, but how many of you say that 5 divides 0 is 0? Okay, good. What is it then? Undefined. Okay, that's what you meant to say. It's undefined. So that vertical line has an undefined slope. Okay. What do you think L2's slope is going to be? So this was undefined. And if we work this one out, we would also get undefined. Okay? Vertical lines have undefined slopes. So if I look at these two lines now. Oops, sorry. We're done yet. Let me pause. So if I look at these two lines, we'll just say L1 and L2. Give me 2 points on this one. Let's say this point right here and this point right here. What's the ordered pair for that first one? 1, 3. What's the ordered pair for this one? 6, 3. And so, remember, it's y2 minus y1. I'm just going to say point 1, point 2. And so y2 is 3, y1 is 3, x2 is 6, x1 is 1. So you get 0 over 5. What's 0 divided 5? What is it? 0. 0 divided by any number is 0, right? What do you think the slope of line 2 is going to be? 0. So horizontal lines have a 0 slope. Okay? It is defined, it's the number 0. Where vertical lines have an undefined slope because they force you to divide by 0, which is against the rules for math. Okay? Now all the other lines will have some number for a slope that's not 0. So all other lines will have some other slope. And they might be a fraction, might be a whole number, might be negative, might be positive. Okay? I want to make sure that you saw vertical and horizontal lines, because those are usually what trip you up the most. Any questions on these? You might not finish with this? some other lines. If they're not vertical or horizontal, sometimes they call them oblique. Okay? It just means they have an angle to them that's not vertical or horizontal. So I'm going to pick a couple points like this one and this one. And over here I'm going to pick this one and this one. And the question is, are lines 1 and 2 parallel? Are lines 1 and 2 parallel? You can't really label lines and numbers, but I did here because I'm not focused on the labeling here. I'm focused on how do we figure if they're parallel or not. So how will I know if those lines are parallel or not? Yeah.
Finding the slopes.
Find the slopes, and what's special about the slopes will tell me if they're parallel.
If they're equal.
If they're equal, then the lines are parallel. If I don't get the same number for my slopes, then the lines are not parallel, right? So if you just drew this on your paper, make sure you identify the same ordered pairs we have, because your picture probably isn't, I mean, it's not on grid paper, so it's probably not perfect. So make sure you put the points in here. What is this one down here? -3, -2. Someone else. What's this one up here? 0, 4. Someone else. What's this one over here? 4, 1. Thank you. And someone else? This one? 3, -1. Okay? So those are 4 points that we've identified are on these two lines. And so if we take line 1, find the slope of it. Remember the formula? How do I find it? y2 minus y1. I'm going to call this point 2 and this point 1. Anybody know why? Because 4 minus 2 isn't negative, is it? If I can avoid negatives, sometimes I'm going to. So 4 minus 2, the y's, over the x's, which is 0 minus a -3. And minus the -3 becomes a positive. So on top I get 2, and on the bottom I get 3. Okay? What do you think? Are they parallel? Do they look parallel? Do they look at Thomas? Just look at them. Do they look parallel?
Yeah, they do, but that should be a -2.
It should be a -2?
Yeah, because it's in the.
Oh, yeah. You're right. Thank you. Minus a -2, which makes that plus a positive, which is 6/3, not. And that reduces to 2, right? You can leave it as 2/1, but if you're not actually graphing, then you want to reduce your number, and you don't want it to be a fraction unless it has to be a fraction. If you're being asked to graph a line, then you want it to be a fraction. Okay? Yeah, I should have caught that. Good catch, Thomas. Looking at line 2 now. Why? Again, I'm going to call this point 2 and point 1. And so 1 minus -1 over 4 minus 3. What's 1 minus a -1 become? 2. And 4 minus 3 is 1, which is 2. So are they parallel?
Yes.
Yeah. Had Thomas not caught our mistake, we would have said 2/3 and 2, and we'd said they weren't parallel, but they definitely are. Okay? Any questions on that? I have an example here I want you to try in just 1 seconds. Ready? Anybody not ready? Find the equation of the line. I guess I won't turn you loose on this altogether. This is quite a bit more involved than what we just did. Find the equation of the line parallel to this line and passes through the point 6, -1. So if it's parallel, what's special about it?
Same slope.
What is equal? The the slope's up. So the question is, what's the slope of this line?
3.
3. How do you know that just by looking at it?
Because
It's in mx plus b, meaning slope-intercept form, right? And Brianna, where's the m at?
before the x.
Yeah, right in front of the x. Now, to do that though, it has to be solved for y, doesn't it? To make sure it's in the form of slope-intercept. If it's not in that form, then I can't just look at the number in front of the x. But this one is, so the slope of this line is 3. So that means the slope of any line parallel to it would also be 3. Now they don't just want to know the slope, they want us to write an equation. And so remember, to write an equation, I always go back to this method, this form. Anybody remember the name of this form?
Point slope.
Point slope, nice. And what goes in this first box? Y1. What goes in the second box?
X1.
M. What goes in the third box?
X1.
X1. That's why we're reviewing it. We don't have that mastered yet. You'll get it. All right, so what does 6 represent? X1. What's negative 1 represent?
Y1.
Y1. And so if I plug them in now, negative 1 goes here, 3 goes here, 6 goes there. That wasn't hard, was it? Did they say how to leave my equation? No, so if they don't tell me, I'm just going to leave it like that. The only thing I'm going to do is clean it up and remove my boxes and stuff. And minus a negative becomes plus 1. And I don't want you to do anything else. But now, if you say, I don't like it in that form, I want to write in slope-intercept form, well, that wouldn't be hard. I would distribute my 3 and then subtract 1 from both sides, right? Distribute my 3 and then I'd move my 1 over. Then it'd be slope-intercept form. And if they didn't like that, or if they wanted standard form, then I'd move my x term over here. And if I had any fractions, I'd multiply everything by the denominator. And then I'd try to make the a term positive, the number in front of the x positive. Okay? But this answer right here is good enough. It says write equation, that's the equation. And if my answer is in, my answer key has it in standard form, and you have this, even though they're not all the same, I can glance at the problem and glance at your answer, and I know whether it's right or wrong just by looking at it very quickly. Okay, so it's not an issue with me if you don't have the same form as my answer key has. So if they don't tell you to change it, don't, because this is what happens. Ariana will do the problem and leave it like that and get full credit. Emily will do the problem, she'll have this right, but then she'll transform it wrong, and it's no longer right. And so I have no choice but to take something off. Now I don't hammer you and take 4 of the 5 off, but I do take 1 off, and I would circle this answer, because that was right, but down here I'd probably circle your mistake and then say -1. So Ariana did the same work to here. They both had the same answer, and she got full credit, and Emily missed a point because she changed it wrong. Okay? So don't do extra work on the test if they don't ask for it. Right, moving on. Slopes of perpendicular lines. Oh, sorry, this is rule 2. Someone last year says, you have rule 1 but no rule 2. Yeah, this was rule 2. Slopes of perpendicular lines have a product of -1. Horizontal lines are perpendicular to vertical lines. Remember the slope of a vertical line?
Undefined.
Undefined. And the slope of a parallel line? 0. If I take 0 times undefined, I don't get -1, do I? So this right here is just covering the fact that their slopes really don't multiply to be -1, but they are perpendicular. And so this rule is just covering that. Alright? And we have some examples here we'll do in 1 second. Alright, so the slope of in this first example here, the slope of one line is 3. The question is, what's the slope of the perpendicular line? And so, what times 3 will give me -1? Yeah, -1/3. You're right, it's got to be negative. And then 1/3 times 3 over 1 is -1, right? So the slope of the perpendicular line is going to be -1/3 because 3 times -1/3 is -1. This is really 3 over 1, and my 3's cancel. I get a negative times a positive is a -1. Okay? So what's the slope of this perpendicular going to be? This slope is -2/3, so it's, okay, so if we leave it as improper, what is that? 3 over 2. Is it going to be positive or negative? Positive, because this negative times this positive will give me a negative number, right? If I go -2/3 times a positive 3/2, the 3's cancel, the 2's cancel, I'm left with a negative times a positive is -1. Okay? So in the last one here, what's my slope going to be? 4 over 1? Let's try that. What are you saying, Silas?
-4/1.
Negative, because a positive times a negative is a negative, right? And we have 1/4 and -4/1. Now, do I have to show the 4 over 1? No, I could just call it -4, right? But if I wanted to show how they cancel, I would probably put a 1 there. Now the 4's cancel, I get positive times negative is a -1. Okay? Now, a few years ago, I had Mrs. Johnson. You probably have had her as a sub in or Miss Ray's class for sure, if you have Spanish. And she's been in for a few other people. She'll be in for me whenever I can figure out how to make sure the program calls her first. Anyway, I had her, and she told me a little something, told the kids a little something that helped them remember it. She called it that flippy switchy thing. And the reason she said that is to find the slope of a perpendicular, you flip the number and change the sign. So she's saying flip the number and switch the signs. So from now on, I will refer to this as that flippy switchy thing. I'll say, remember that flippy switchy thing? And so to find the perpendicular slope, we flip the number over and switch the sign. Yeah. So to find the slope of a perpendicular, flip the number and I should change my word change to switch. So it matches my flippy switchy phrase. Okay. I'll pause while you finish copying it down. So it's really important you remember two things. Parallel slopes are what? The same, so they're equal. And perpendicular slopes are louder.
The line that crosses with the other line at 90 degrees.
Okay, and so what do I know about their slopes?
Opposites.
They're opposites and they're reciprocals, right? So we apply this flippy switchy thing to it to find the perpendicular slopes. Okay? So find the equation of a line perpendicular to 3x plus 2y equals 7. that passes through 3, 2. I'll let you copy that down and we'll do that. I think this is the last example. So, first of all, we want to find the equation of a line perpendicular. So anytime we find the equation of a line, we're looking at y minus, we're looking at this. What goes in the first box? Y1. What goes in the second one? M. And the third one? X1. Do I know M yet? Did they say slope is? No. So we have to find that, right? Okay, do I know Y1 and X1? Yeah. So let's plug them in right now. What's Y1? 2. And what's X1? 3. So all I have to do is find the slope. So first of all, let's find the slope of this line. Okay? How many of you think it's 3? Yeah, some of you want to, but you're like, yeah, I'm not seeing a lot of hands. Remember, it's not in slope-intercept form, is it? So those who are cautious and say, I'm not so sure, you might be trying to trick me. I did. I was trying to trick you because it's not in slope-intercept form. Right? What form is it in? Standard form. Some people will look at this and say, oh, I know the slope. Just by looking at it, they don't have any work to do. Because they understand what I'm about to show you. Okay? Now, you don't have to copy this down. You don't even have to use it. If you want, you can take that equation and solve for y every time. Okay? Because I could take this equation, move my 3x over, divide by 2, and solve for y. But I'm going to do it with this. ax plus by equals c. C, not 0, sorry. Okay? And I'm going to move my ax over by minusing ax. And so I get by is equal to negative ax plus c. And then I'm going to divide everything by b. And so y is equal to the opposite of a over b, x, plus c over b. If I want to know the slope, does this have anything to do with it? No, it doesn't. If I want to know the slope, does this have anything to do with it? Yes, it does. So what we just proved here is if my slope, or if my equation is in standard form, my slope is always going to equal the opposite of a over b. Always going to equal the opposite of a over b. So if I go back up here, what's a? 3, and what's b? 2. So my slope is the opposite of 3 over 2. Or negative 3 over 2. Now, is that what I put in here? Yeah, unfortunately, many of you will. We're finding the line that's perpendicular. So if this slope is negative 3 over 2, what's the perpendicular slope going to be? A positive 2 over 3, right? Flippy switchy thing, flip it over, switch the sign. So flip it over is 2 over 3, change the sign, becomes positive. So my slope that I want is 2 over 3.
Can you go back down for a second?
Go down. Okay. Now, if you can remember standard form, the slope is the opposite of a over b, then you can go right to the slope of that line. You don't have to do any solving or working or anything. What would be perfect for me if it was a homework question, you're showing your work, you would say this. You go m equals opposite of a over b equals negative, what do we have, 3 over 2, okay? And then if you had to show the perpendicular slope underneath it, then you could just write, change the sign, flip it over, 2 over 3. Okay? So that's how we find it. And so that's the number that goes in there. And again, if they didn't tell me, we're almost done. If they didn't tell me how I had to leave it, just leave it like this. Don't go through the work of switching this around. Okay? Any questions? We're doing the odds. 231, so we have 16 problems to do. I'll upload this, so if you missed something or want to see it again, you can